Good morning. This is morning here while I'm making this video. If you're watching it in the afternoon, good afternoon. If you're watching it in the evening, good evening. So there, I've covered everything. Well, how's the semester going? All A's, right? I have a little information here that I wanted to share with you. It's kind of interesting. Again, it's about the neuron. Now, in some areas, I may repeat myself. However, given my age, that's my privilege to repeat myself. But I do want to go over a couple of items with you, and so this video will talk about another video, and if you have any questions, any concerns, let me know. I'll certainly be glad to address them. Hopefully, when I address them, that will be satisfactory. I do appreciate your work. I have to say that. I appreciate what you folks have been doing. I think that you've been doing a pretty good job in your responses. And so I just want to let you know that I appreciate that. Now I'm going to go over a few things. I'm going to go to the document cam. There's a few words that I want to go over with you and check with you. And because we have a new concept, somewhat of a new concept anyway, that's coming up, that I feel as though you may find interesting. And having said that, I'm going to go ahead and look at what we have here. One of the first aspects that we have here is starting at the smallest and going to the largest. We start with genes. Genes are real small. They give us our characteristics. Brown hair, black hair, bald hair, and all of these. So we go from the genes, and then we go to the chromosomes which contain the genes. Then, and we have 23 pairs, 46. Then we go to what is called a genome. And this genome is a map of our inherited characteristics. Then we go to what we are looking at now. We are going to connectomes. Connectomes. This is the new aspect that is going to be brought out, and it's going to be brought out in a video in the same section, so you will have an opportunity to view it. Okay, then a couple of things I want to talk to you about is the fMRI, functional magnetic resonance imaging, and PET, positron emission tomography. But the fMRI detects blood flow. And this is what I find interesting. The individual had a 23-year-old comatose female, absolutely on life support, wasn't able to communicate in any way. And if you would take the life support from that individual, probably wouldn't have been with us too long. So I want to emphasize this. This is the blood flow. fMRI is the blood flow. Now what they did, now this individual, you have to understand there was no movement, there was no recognition of her environment. She did not acknowledge anything. She just laid there in a vegetative state. Now here's what is interesting. They hooked up the little electrodes, to the brain and so forth. And they suggested to her, now evidently I would think that she had been an athlete at one time, but they suggested to her playing tennis. Now you have to understand that she's comatose, vegetative state, no movement. And so they suggested to her, imagine playing tennis. And then they monitored her brain. Now, from this suggestion of playing tennis, 2 areas of her brain lit up. And they were able, through the fMRI, to measure the blood flow. 2 areas of her brain lit up. One of the areas was leg movement, and another one was arm movement. Now, we think, how is this possible? And it's just one of the unique aspects that we have of science. Then, talked about that, and PET measures the metabolic process of the mind. And here's what we're looking at here. We're looking at, and we've talked about this before, and you're acquainted with this, we talked about the action potential. We have a neuron here, and we have a cell body here. We have the axon here, and then we have the area that permits the neurotransmitters to go across the synapse and connect with another neuron. Right here, we have myelin sheath. Myelin sheath. Myelin sheath that is made by the glial cells. The glial cells make the myelin sheath. Wrap around the axon, wrap around the axon. And the more it wraps around the axon, the better transmission that we have. Now this here is called the action potential. It is the pump, sodium-potassium pump, that forces the message down the axon, and so we have electricity working here, and it forces the electricity down and releases the message. Now, I just want to make this straight. We look at this, and the text described it as a type of explosion. Now, I appreciate biology, and I appreciate all that biology does, but what we're going to do, just for my sake, kind of humor me a little bit, we're going to call this the Big Bang Theory for this action potential, because we're not getting into voltage there as far as electricity forcing the message down the axon, but we should be aware of it. This part here, remember, is the myelin. Myelin develops. Some individuals are not fully myelinated, and this is mostly males, but some individuals are not fully myelinated until they're in their 40s. Usually, this is the starting of adulthood when individuals are fully myelinated. Now, how do we tell whether they are fully myelinated? Not quite sure. That's up to science, but what they consider fully myelinated. A fully myelinated person then distinguishes themselves from a teenager, an emerging adult, into true adulthood, which takes place at about the year 26. Now, having said this here is kind of interesting because we have here what is called the myelin sheath. This here is all the myelin sheath, or MS. MS. Okay, remember these are the glial cells that wrap around here. The more we learn, the better we learn. The more this wraps and kind of protects the axon from receiving other messages while new information is coming in. So we call this the myelin sheath. Now here's the interesting point that I want to make is, and you've heard of multiple sclerosis. Okay. Both with the initials of MS. This here is myelin sheath. This here is multiple sclerosis. Myelin sheath is the development of this area right here on the axon. Multiple sclerosis, one of the things that multiple sclerosis does is destroy this myelin sheath. Now the reason I'm bringing this out, that if we remember MS, myelin sheath, we can connect it with MS, multiple sclerosis. So that's basically what I'm going to be talking about now. That's what I wanted to cover with you. I wanted to make sure then that you were able to go from the gene stage to the chromosome to the genome to the connectomes. And this is what we are going to be looking at in this section, a video on connectomes. Again, I want to thank you folks for the wonderful work that you've been doing, for your communication with one another and with me. I think it's great. I hope that you are able to grasp the material. If you're not, send me an email message. Give me a phone call. Whatever you would like to communicate to me that you are not grasping the message. A lot of material. There's a lot of material. But we want to understand that material, because remember that this class is built on success. So until I see you next time, you folks have a good day or a good week. Okay, bye.